Hi everyone and welcome back to RNN LAB. Today I am presenting a project that is a bit different from our usual Arduino or electronic circuits. While there is still an electrical component, it is not very sophisticated. The real heart of this project is the mechanics, and the final result is truly impressive. As you saw in the introduction, this is an animated object, a blend of pure mechanics and construction technique. This was an idea I had in mind for many years, but I never had enough time to start. Finally, I decided to take the time to build it and share it with all of you. There is a full week of intense work behind this video, between the actual building and the editing process. As always, my personal challenge is to create everything using recycled or low-cost materials that are easy for anyone to find. I use my imagination, technical skills, and experience to bring these ideas to life. This is a long and demanding video. I chose not to cut anything out because I wanted to show the real process, but I had sped up some parts to keep it moving. I know it's a long watch, but I believe those who love engineering will have the patience to see it through to the end. I want to clarify one important thing: this project was built on the fly. There are no blueprints or drawings. The entire design happened in my mind during the construction. You will see tests, mistakes, discarded parts, and measurements taken in real time. The core of the project is the synchronization of 7 different components powered by a single, small gear motor. The most critical part was creating the crankshaft. To give you an example, it is like building an engine's crankshaft from scratch, but with 7 distinct movements. Consider that a standard 4-cylinder engine has movements synchronized in pairs. Here, every single movement is unique and must be perfectly coordinated. In the video, you will see every step of the way. For anyone who wants to replicate this challenge, I will put the mechanical diagrams in the description. If you have any questions, leave a comment and I will be happy to help you. Now, I'll leave you to the rest of the video. Talk to you later. This project is a replica of a manta ray, a cartilaginous fish from the Myliobatidae family. These are the giants of the sea. They can reach up to 7 meters in width and weigh more than a ton. They inhabit all warm and temperate oceans, from the Atlantic and Pacific to the Mediterranean Sea. The manta is a majestic creature with a fantastic style. Its motion is the definition of perfection in movement. I wanted to replicate that motion, and although the result achieved in my project is incredible, I must admit, mechanically, it is truly impossible to fully match the natural elegance of this fish. This makes us realize that nature cannot be equaled. No matter how advanced our technology becomes, reaching levels beyond our wildest dreams, we can never truly compete with the biological perfection of humans and animals. Remember this small anecdote: the best camera in the world is and always will be the human eye. But I don't want to dwell too long on these philosophies. I will now leave you to the rest of the video. I want to give you some details about the materials and techniques I used. My goal was to achieve professional results using only inexpensive or recycled materials. For this project, I used pressed cardboard, scrap wood profiles, and simple clothes harness. For the finish, I used super glue and, believe it or not, soy sauce. The electronics are very basic: a small gear motor, 2 lithium batteries, and a switch. To create the transmission system, they made custom pulleys out of wood scraps. I cut the wood with 2 different sizes of hole saws and then refined the pieces by using my drill as a small lathe, sanding them down with sandpaper. I used the same method for the motor pulley. Unfortunately, I couldn't film this part because I had to work outside the lab, and I don't have a camera set up for outdoors yet. On the pulleys, I added O-rings on both sides to hold the transmission belt, which I made from simple rubber bands. I used 8 of them together to ensure a strong, durable tension with great grip. The structure is quite large, with a 48 cm wingspan, and theoretically it should have used gears. However, since gears aren't easy for everyone to find, I designed the simplest and most cost-effective movement possible. It was a challenge, but with a bit of imagination and basic physics, you can achieve amazing results. You will see the whole process in about 40 minutes, but for me, it represents a full week of hard work. As you will see in the video, to create the eyes of the Manta Ray, I used 2 glass spheres. I salvaged them from whiskey bottles, where they are used as non-refillable pour valves integrated into the plastic cap. As I always say in my videos, I recover everything that can be recovered. Even if an object doesn't seem to have a specific purpose at the time, sooner or later it will find its use. In my lab, nothing is thrown away, every little scrap is just waiting for the right idea to come back to life. For the connection between the body and the wings, I needed a smooth 180-degree movement. I decided to use common paper clips. I shaped them by hand into eyelets to create a sort of mechanical hinge. As you will see in the video, the concept is simple, but it takes time. Not just to make the individual pieces, but especially for the assembly, everything must stay perfectly aligned so the movement doesn't bind. A project like this requires time and a lot of patience, but in the end, the result is worth all the effort. I want to add a quick note for anyone who wants to replicate this work. You must understand that there is no room for rushing here. It takes true passion because every single component is scratch-built and handcrafted. As you may have noticed in the video, I coated and reinforced all the cardboard with super glue. This is a simple trick to create a solid and sturdy structure. As I've explained in past videos, when the cardboard fibers mix with the super glue, a chemical reaction occurs that turns the material into something similar to plastic. With this coating, as you can see, the color changes to a deep dark brown. With some skill and patience, we can achieve a wood-like effect. Later in the video, when I finish it with soy sauce, it will look almost like burl wood. It's a visual effect I truly love, that weathered classic wood style with a touch of the future inside. A magical mix of reality and imagination. And on that note, I want to share one of my little pearls of wisdom. Where reality ends, imagination begins. To me, this means that there are no fixed standards, and that is the beauty of the game. Now, back to the video. now moved on to the finishing stage with soy sauce. As you will see, the final result is fantastic. We will apply this treatment to the entire structure, including the wooden base. Once finished, you won't be able to tell which part is real wood and which is cardboard. This effect fascinates me deeply. I love creating that mystical atmosphere that recalls the art of the old Renaissance masters. When this style blends with technology and the future, something special is born, almost like a fairy tale, the kind you can see with your own eyes, but can't quite find the words to describe. Now, let's prepare the supports for the rods that move the wings. As you will see, these supports are made from popsicle sticks, glued and coated with super glue to make them strong. Then, I drilled them to house the rods for the wing movements. The rods themselves are made from clothes hangers, an excellent material for this project because it is easy to find, cheap and very sturdy. They need to be shaped carefully to create eyelets, which will then be connected under the wings to other eyelets made from paper clips. This project requires a lot of manual skill and a great deal of precision work. As you have seen so far, preparing the crankshaft was a painstaking process. For the rods that move the wings, I initially used wooden skewers. These were essential for taking correct measurements without wasting the metal rods. Using the wood, I was able to find the exact angles and then transfer the final measurements onto the metal. This was true real-time engineering. I wanted to show you that nothing is simple. Often, when watching tutorial videos, everything looks effortless, but the reality is quite different. I could have prepared everything beforehand and only shown the assembly, but things aren't that easy. Seeing the creation live, including calculations, mistakes, and corrections, takes time, but it's the only way to show how an idea truly comes to life. Now, let's move on to the final assembly. I'm installing the gear motor with the pulley I created earlier, positioning it perfectly in line with the crankshaft pulley. I'll solder the wires, the switch and the battery pack, which will be housed in the back of the base. I'm placing all the components, the rods, the supports, and finishing the entire structure with soy sauce as I assemble everything. I'm securing the supports on the shaft using pins made from paper clips, and adding the final touches to make the design perfect. The work has been very demanding, but seeing it almost finished is incredible. I'm truly satisfied with the result. I want to close this video differently than usual. I have prepared a special ending and I don't want to break the atmosphere I've created, so I will let the melody take over. Thank you so much for joining me in my lab. I hope you enjoyed this project and that it inspired you to try and replicate it. Please feel free to leave a comment, subscribe to the channel, give it a like and turn on the notification bell. Sharing this video is very important to help the channel grow and to allow me to bring you even more interesting and high quality content. Thank you once again. I'll leave you now to enjoy the final reveal, which I hope you will like. See you in the next video. Bye.